Hello everyone, in this video I am going to explain about image restoration in the presence of noise only. If you like this video, please subscribe to my channel and share to your friends. So already we know that the spatial filters are used for image smoothing and sharpening. But the other advantage of these spatial filters are they are used to remove the noise. That is nothing but by removing the noise we can restore the image by using these spatial filters. So here we have two types of spatial filters are there. They are mean filter and order statistics filter. So here the difference between these two filters are the mean filter is based on the concept of convolution, whereas the ordered statistic filter does not use convolution but only orders the pixels of the neighborhood and selects a pixel value based on its order. That is nothing but based on its rank. In next slides we will discuss clearly about these mean filters and order statistics filter. So order statistics filters are a general form of filters that are not based on convolution. The pixels that come under the mask are simply ordered. That is, the pixels come under the mask, they are arranged in ascending order. Then depending on the filter requirement, based on the predetermined value of n, the nth value of the list is chosen and this value replaces the center pixel. That is nothing but the pixels are arranged in a order, that is in ascending order. In that we will choose either a middle value pixel or minimum value pixel or maximum value pixel. The order statistics filters are differentiated based on how they choose the values in sorted list. So the position indicates the rank. So for example, here we are taking this image, that is a 3x3 image. Now we will see the order statistics filter application by applying on this image. So the first filter is the median filter. So for the median filter, selects the middle value in the sorted list. The procedure for implementing the median filter is as follows. That is, first we have to read the pixel value and sort the list and choose the median, that is nothing but center value. So here first we will take that image and we will arrange all the pixel values in ascending order, that is 12, 13, 14, 15, 17, 18, 19, 20, 21, like that. We will arrange all the pixel values in ascending order, and after that we will choose that middle value of this list. So here the middle value of the list is 17. So that 17 is replaced by this 14 value pixel. So this is the original image, and after removing the noise, here this 14 is replaced by 17. Next filter is the maximum filter. So here we will sort the pixel values in ascending order of this image. So in this image we will choose the maximum value, that is 21. So that 21 is replaced by this 14 value pixel. So this is about that maximum filter, and after that we have minimum filter is there. So here the pixel values are arranged in ascending order, that is we will sort that pixel values in ascending order of this image, and we will choose that minimum value. That minimum value is replaced by this 14 value pixel, that is nothing but the center pixel, that is 14. So here we have the 14 is replaced by 12. So this is about the minimum filter. And next we have another filter is there, midpoint filter. In this midpoint filter we will choose minimum value and maximum value, that is 12 and 21. We will do addition, that is 12 plus 21, and after that we will do average. That is nothing but 12 plus 21 by 2, that equal to 33 by 2. That value is approximately is 17. So that 17 is replaced by this 14 value. So like this we will use this midpoint filter. That is nothing but the 17 value is replaced by the center pixel of this image, that is nothing but 14. This is about that midpoint filter. The next filter is alpha trimmed filter. So in this alpha trimmed filter we will take a threshold value t. So based on the threshold value t, we will remove that left and right pixel values in the sorted list. So here this is the image we have. So we sorted the list in ascending order, and here when the threshold value t equal to 2, then we will remove the 2 pixel values at left side and 2 pixel values at right side. So if the threshold value t is 3, then we will remove 3 pixels at left side and 3 pixels at right side. So here we are taking t equal to 2. So 12, 13 is removed at left side and 20 and 21 removed at right side. So that we got the pixel list, that is 14, 15, 17, 18, 19. The average of these pixels is given as 83 by 5, that is nothing but approximately equal to 17. So this 17 is replaced by the center pixel value 14. So this is about alpha trimmed filter. And next one we have mean filters are there. Those are arithmetic mean filter, contra harmonic mean filter, geometric mean filter, harmonic mean filter. So the first one is that arithmetic mean filter. This arithmetic mean filter removes local variations within that image. So it is similar to the low pass filter. So this filter is very useful for removing Gaussian noise and uniform noise. And next filter is contra harmonic mean filter. So this filter is useful for removing either salt or pepper noise. So here this is the formulation which is given for this contra harmonic mean filter, where R is the order of the filter and W is the window size. A negative value of R eliminates salt type noise and a positive value eliminates pepper type noise. So this is about contra harmonic mean filter. And next one we have geometric mean filter is there. This filter eliminates Gaussian noise but is ineffective for pepper type noise. So it is represented by this formulation. Here this is the formulation for geometric mean filter. And next one we have harmonic mean filter. This works well for removing salt type noise and Gaussian noise. The formulation for this harmonic filter is here. So there is nothing but n square by summation of f of x comma y. So thank you very much for watching this video. To watch more videos, please subscribe to my channel, Open Box Education.